You're listening to leadai.dev, your daily updates on AI development. Today's topic is Agentic AI memory attacks, cross-session security threats organizations face. Here's a quick overview. Security researchers expose critical vulnerabilities in agentic AI systems where memory attacks persist across user sessions, creating unprecedented enterprise risks. Now, let's ask our analyst about these developments. What's new? Agentic AI memory attacks exploit cross-session vulnerabilities?
Security researchers have uncovered a critical class of vulnerabilities in agentic AI systems where memory attacks can persist across user sessions and spread between different users. Unlike traditional AI security threats that remain isolated to individual interactions, these agentic AI memory attacks exploit the persistent memory capabilities that make AI agents effective at maintaining context and learning from previous interactions. The attacks work by injecting malicious instructions or data into an AI agent's memory during one session, which then influences the agent's behavior in subsequent sessions with the same or different users. The technical mechanism behind these attacks leverages the way agentic AI systems store and retrieve contextual information across conversations. When an attacker successfully injects malicious content into an agent's memory store, this content becomes part of the agent's learned context and can be retrieved during future interactions. The persistence occurs because most agentic AI implementations use vector databases or similar storage mechanisms that maintain embeddings and contextual information to improve performance over time. This creates a scenario where a single successful injection can compromise not just the current session, but potentially hundreds or thousands of future interactions. Traditional AI systems processed each query independently, making attacks limited to single interactions. However, agentic AI systems are designed to maintain state and context across sessions, fundamentally changing the attack surface. The memory persistence that enables these systems to provide better user experiences also creates pathways for attackers to establish persistent footholds within AI infrastructure. This represents a paradigm shift in AI security where the benefits of memory and context awareness come with significant new risks that most organizations haven't adequately addressed. Memory injection attacks can persist for weeks or months in agentic AI systems without detection. Cross-user contamination occurs when infected memory influences interactions with different users. Vector database storage mechanisms amplify attack persistence across system. Restarts traditional AI security measures fail to detect memory-based persistence attacks. Attack success rates increase with longer agent deployment times and larger memory stores.
Thank you for that analysis. Let's move on. Who benefits from understanding agentic AI memory attack vectors?
Enterprise security teams and AI infrastructure managers face the most immediate need to understand these attack vectors. Organizations deploying customer facing AI agents, internal productivity assistants, or automated decision making systems must evaluate their current security postures against memory based attacks. Companies in financial services, healthcare, and government sectors where AI agents handle sensitive data face particularly high risks. Security architects responsible for AI governance frameworks need to incorporate memory attack scenarios into their threat models and incident response procedures. AI development teams and ML ops engineers also require deep understanding of these vulnerabilities to implement proper safeguards during system design. Platform engineers managing multi tenant AI environments face complex challenges in preventing cross user contamination through shared memory stores. Compliance officers in regulated industries must assess whether current AI deployments meet data protection requirements when memory attacks can cause data leakage between users or sessions. Risk management teams need to quantify potential exposure from persistent AI compromises that traditional security tools cannot detect. Organizations still in proof of concept phases with agentic AI should pause deployment until proper memory security controls are implemented. Companies using third-party AI agent platforms may have limited visibility into memory architecture and should demand security audits from vendors. Small teams without dedicated security resources should consider managed AI services with built-in memory isolation rather than self-hosted solutions that require specialized security expertise. Enterprise security teams managing AI-powered customer service or internal productivity tools, AI development teams building agentic systems with persistent memory capabilities, compliance officers in regulated industries deploying conversational AI interfaces, platform engineers managing multi-tenant AI environments with shared resources, risk managers evaluating AI deployment strategies and security, investment priorities.
Great insight, really helpful context. How to implement agentic AI memory security. Step-by-step protection.
Begin by conducting a comprehensive audit of your current agentic AI deployments to identify memory storage mechanisms and data flow patterns. Map all persistent storage components, including vector databases, conversation logs, user preference stores, and any caching layers that maintain state between sessions. Document the data retention policies, access controls, and isolation mechanisms currently in place. This audit should include testing for cross-session data leakage by creating test scenarios where information from one session appears inappropriately in subsequent sessions. Implement memory isolation controls by creating separate memory namespaces for different users and session contexts. Configure vector databases with proper tenant isolation to prevent cross-contamination of embeddings in stored context. Set up regular memory sanitization procedures that scan for anomalous patterns or potentially malicious content in stored memories. Deploy monitoring systems that can detect unusual memory access patterns or attempts to inject persistent instructions. Establish automated memory rotation policies that limit how long specific memories persist in the system. Validate your security implementation by conducting red team exercises specifically targeting memory persistence vulnerabilities. Create test scenarios where attackers attempt to inject malicious instructions that persist across sessions. Monitor system behavior during these tests to ensure isolation controls prevent cross-user contamination. Implement logging and alerting systems that can detect successful memory injection attempts. Regularly review and update memory security policies as your agentic AI systems evolve and new attack vectors emerge. Audit existing agentic AI deployments for memory storage components and data flow patterns. Implement namespace isolation in vector databases and memory stores to prevent cross-user contamination. Deploy automated memory sanitization scanning for anomalous patterns and malicious content. Establish memory rotation policies, limiting persistence duration of stored contextual information. Conduct regular red team exercises targeting memory injection and persistence vulnerabilities. Monitor memory access patterns and implement alerting for suspicious injection attempts.
That's a very interesting point. Tell us about competitive context. How memory attacks change AI security landscape.
Traditional AI security solutions focus on input validation and output filtering, making them inadequate for detecting memory-based persistence attacks in agentic systems. Companies like Anthropic and OpenAI have begun implementing constitutional AI approaches that include memory safety considerations, but these solutions primarily address content generation rather than persistent memory contamination. Enterprise security vendors such as Palo Alto Networks and CrowdStrike are developing AI-specific security tools, but most current offerings lack visibility into agentic AI memory stores and cross-session attack vectors. The emergence of memory attacks creates significant advantages for organizations that implement proper isolation and monitoring controls early. Companies with robust memory security architectures can deploy agentic AI systems with greater confidence, while competitors face potential security incidents that could damage customer trust and regulatory standing. Organizations using cloud-based AI services may have limited control over memory architecture, creating dependencies on vendor security implementations that may not address these specific attack vectors. This creates opportunities for security-focused AI platform providers to differentiate through memory isolation capabilities. Current limitations include the performance overhead of implementing strict memory isolation, which can reduce the effectiveness of context-aware AI agents. Many existing agentic AI frameworks lack built-in memory security controls, requiring custom security implementations that increase development complexity. The detection of memory-based attacks remains challenging because malicious content may be subtle and designed to blend with legitimate stored context. Organizations must balance security controls with the user experience benefits that persistent memory provides. Traditional AI security tools cannot detect persistent memory contamination across sessions. Major AI providers are developing constitutional approaches, but lack comprehensive memory security. Enterprise security vendors are building AI-specific tools without agentic memory visibility. Early adopters of memory security controls gain competitive advantages in AI deployment confidence.
Good analysis. Let's continue. What's next? Future implications of agentic AI memory security.
The discovery of cross-session memory attacks will likely accelerate the development of specialized security frameworks designed specifically for agentic AI systems. Major cloud providers are expected to introduce memory isolation features as standard components of their AI services, similar to how container orchestration platforms evolved to include security controls. Regulatory bodies may begin requiring specific memory security controls for AI systems handling personal data, particularly in industries like healthcare and finance, where data contamination could have severe consequences. The emergence of memory-focused AI security startups is anticipated as traditional security vendors adapt their offerings. Integration with existing security ecosystems will become critical as organizations seek to incorporate agentic AI memory monitoring into their CM and SOC workflows. Development of standardized APIs for memory security monitoring will enable better integration between AI platforms and enterprise security tools. The evolution of AI agent architectures will likely include memory security as a fundamental design principle rather than an afterthought, similar to how secure coding practices became standard in software development. Long term implications include the potential for memory attacks to become a primary vector for AI system compromise, requiring fundamental changes in how organizations approach AI security. The development of adversarial AI techniques specifically targeting memory persistence may lead to an arms race between attackers and defenders in the agentic AI space. Organizations that establish strong memory security practices now will be better positioned for future regulatory requirements and customer trust expectations as agentic AI becomes more prevalent in business critical applications. Cloud providers will integrate memory isolation as standard AI service features within 12 to 18 months. Regulatory frameworks will mandate memory security controls for AI systems handling personal data. Specialized AI security startups will emerge focusing on memory-based attack detection and prevention. Memory security will become fundamental to agentic AI architecture design principles.
Great analysis. So, what are the key takeaways from all of this?
Implement memory namespace isolation immediately in any agentic AI deployment to prevent cross-user contamination. Establish automated memory sanitization scanning to detect malicious content persistence across sessions. Conduct regular security audits specifically targeting memory injection vulnerabilities in AI agent systems. Deploy monitoring systems that track memory access patterns and alert on suspicious injection attempts.
And what market signals should our listeners watch for?
Enterprise AI security investment acceleration. The revelation of persistent memory attacks in agentic AI systems is driving unprecedented investment in AI-specific security solutions. Enterprise buyers are demanding memory isolation capabilities from AI platform vendors, creating new market opportunities for security-focused AI infrastructure providers. Traditional cybersecurity companies are rapidly developing AI memory monitoring capabilities to address this emerging threat vector. This shift represents a fundamental change in AI procurement criteria, where security architecture is becoming as important as performance metrics. Regulatory compliance pressure mounting. Government agencies and regulatory bodies are beginning to recognize the unique risks posed by persistent AI memory attacks, particularly in sectors handling sensitive data. The potential for cross-user data contamination through compromised AI memories creates new compliance challenges that existing frameworks don't address. Organizations in regulated industries are proactively implementing memory security controls to avoid potential violations as regulatory guidance evolves. This regulatory pressure is accelerating the adoption of memory isolation technologies across enterprise AI deployments. AI platform vendor differentiation opportunity. Cloud AI service providers and enterprise AI platform vendors are recognizing memory security as a key differentiator in competitive positioning. Companies that can demonstrate robust memory isolation and attack prevention capabilities are gaining advantages in enterprise sales cycles. The complexity of implementing proper memory security is creating barriers to entry for smaller AI platform providers while benefiting established vendors with security expertise. This market dynamic is consolidating AI platform selection toward providers with comprehensive security architectures.
What should developers and operators do with this information?
Audit all agentic AI deployments for memory persistence mechanisms within 30 days and implement namespace isolation. Deploy automated memory sanitization scanning before the end of Q1 2025 for any production AI agents. Establish memory security monitoring and alerting systems within 60 days for organizations with customer-facing AI. Conduct quarterly red team exercises targeting memory injection vulnerabilities starting in 2025 for enterprise deployments.
Thank you for listening to leadai.dev. Stay tuned for our next daily updates in this rapidly emerging market.